now that we've taken the time to introduce algorithms, I want to introduce what data structures are. Data structures are the way that we represent and store the data in the computer. And it's typically some type of logical relationship between the other elements of data. So in other words, it's a way of organizing all of our data based on the data itself and also its place or the way it relates to the other data that we're storing. So data structures will also sometimes define the way in which that data can be manipulated. So imagine if you had just a group of people standing out in front of a movie theater, but there was no line form. There's really no way of knowing who's going to go in first or last. But if everybody formed up into a line or a queue, then we know that the first person that went into that line is the first person that gets to come out of the line. So some data structures are going to define just the way we store the data, but some are going to be the way we store the data and interact with the data. But we'll see the distinctions as we move a little bit further through the videos. Now, before we start breaking down all the different characteristics and qualities of data structures, we want to make it clear that pretty much every program that we're going to write will be storing and manipulating data. So data structures are an extremely important concept for us to learn. And that's because the choice of the data structure will have a large influence on how the algorithm actually looks by the end of the day. But also, if we choose incorrectly, if we choose the inappropriate data structure, we could drastically affect the efficiency of our program, how fast it might run, how much memory it might use. And so by choosing the appropriate data structure, we could also affect the maintainability or the extendability of our program. So some data structures given certain applications are easier to maintain and also lend themselves to being expanded. And so as we go through these videos, we're going to talk about these concepts and how different choices interact with different algorithms and how to actually measure those choices and measure those effects. Now, before we get into all that, we want to identify some of the properties of data structures. And we have two main classifications. We have primitive and non-primitive data structures. And the primitive data structures are ones that are the built-in basic low-level structures. And those could be booleans, integers, characters, floating points. And our non-primitive ones are composite. They are ones that are built off of other data structures. So we might have an array of characters, which gives us strings. Or we might have an array of integers, which would give us maybe a list of integers. And we can have a combination of other data structures that might give us graphs or trees or other composite-based non-primitive data structures. There are also linear and nonlinear data structures, where linear data structures are arranged in a sequence. So you can think of an array where you just have them stored one after the other. That's not saying that they have to be in any particular sorted order or anything like that. They're just stored sequentially with each other. Okay? Nonlinear data structures don't have that sequential storage. So you can kind of think of a family tree to where you could go from 5 to 4, or you could go from 5 to 7. You can take different paths throughout the data. So that's the difference between linear and nonlinear structures. Another important property that data structures can have is static versus dynamic. In static data structures, they have a fixed size or a fixed structure that has an associated memory location that typically is defined at compile time. Where in dynamic data structures, they're capable of changing their structure, shrinking, or expanding their associated memory. So the basic examples here are an array. A basic array would be a static data structure, but a dynamic array or a vector would be a dynamic data structure. With all of that said, the biggest takeaway from this video is that data structures are the backbone of every program. Because every program worth its weight is going to be manipulating, storing data, the choice of data structure that we pick is going to drastically affect how good that program actually is. So we're going to spend a lot of time in this video series looking at a bunch of different data structures and the pros and cons behind them and where we might apply them And that's really what's going to launch you into the next level of your career.